Started. So let's get going with study unit 4, and basically let's see how far we can get in an hour's time. Hopefully we can finish it, but if not, we just continue on Thursday with the rest. Also, basically, if I look at when your next assignment are due, it's by the end of May, if that is also not extended. So maybe that might also be extended. But that is on study unit 4 and 5. So I want us to basically have study unit 4 and 5 completed before you need to submit that. And I think we will have enough time to do that. Okay, so let's get into the start of probability. So what we will do in study unit 4 is the basic probability. Study unit 5, we will start looking at discrete probability, Poisson, binomial, and then in study unit 6, we'll start looking at the normal distribution and normal probability. So the first study unit 4, is about just the introduction to probability. So this is also in your textbook, but basically what I want let me get out of a PowerPoint presentation, because I want to show you guys what will be for me the things that you nearly need to see as important. So I think the first part of this portion, if you look at the information given in this part, that they can ask you in a kind of theory kind of question. So and we will have one or two of those in this session as well. So theory, definitely, as you would now have seen in assignment 1, actually it felt assignment 1 of what I've heard a lot of theory in there instead of some of the workings, but in the next few assignments the theory part will be much less. So when you look at probability, basically these first few definitions can be part of a theory question, but then I think what is important nearly is these ones that you need to know. And again, you can use this, you can print this, you can make notes on this, you can use this in the exam as well. So it's not that you're not allowed to use the notes that I give you, so please use it in the exam as well. So basically the things that we will talk about is, if you have probability of A, the rest is the complement. So basically 1 minus that probability of A, and they can nearly show it in 2 ways. Sometimes they have it to the power of C as the complement. Sometimes they write it as this in certain textbooks as well. So sometimes they write it as that, sometimes they write it as A to the nearly to the power of C if you want. So that is the complement. So if I tell you that the probability of A is equal to 0.6, then the complement is 1 minus 0.6. So the complement is just nearly 1 minus whatever the probability was. Then I think the important thing is the two things that they ask or they tell you a lot in the exam, or even in the assignments. They would tell you something is mutually exclusive, or you need to prove it's mutually exclusive. And the other one that they also talk about a lot is independent. So again, we will get to questions in this that we will go through where they talk mutually exclusive or independent. When two events is mutually exclusive, and nearly I want to draw a diagram for you. So if that is probability of A, and you have another one that's probability of B, the two are mutually exclusive because there is no intersection between the two. Okay, so if there is no intersection between the two, there is none that there's a part probability A and a part probability of B. So when you have it that there's an intersection, we know that that part is basically the AND. So it can be that, so let me just write that. So that part is the probability of A and B. So a part of it is because of A, and a part is because of B. So we will show something of that for you as well. So I think the two important ones that you need to remember is basically mutually exclusive and independent. And we'll get to a few of those now as well. Okay, so let's get into it, unless there's any questions before we go into some of the questions that I want to work through. Is there any questions on your side? You can also type in a conversation. You can also just, if there's anything on your side, otherwise we can just continue. Okay, so basically you can get probability questions where in this instance the probability has already been completed, or you can get a table like, let's just quickly see, like in this question where it is the sample numbers and you need to work out the probability. So you can see there's different ways that they can ask it in your assignment and also in the exam. So this one, they already worked out the probability. So let's look at the questions and let's see if we can find it on here and where to look for it and those kind of things. Because again, I think that's sometimes what is the difficulty in probability, is just to see how it makes sense and how to look for certain of the numbers. So let's look at the first option that they give us, and they want us to look for the incorrect one. So the probability achieving a grade of A in marketing. So basically they want you to look for what is the probability of achieving an A in marketing. So achieving a grade of A in marketing, so we're basically looking at that column, and in that column we're basically looking at what's the total, and that is 0.29, so that is correct. Okay, let's look at another one. Achieve a grade of A in statistics. So let's look at where that is. So A in statistics, so we're basically looking at that row. So it is the total. So let's look at what is the total. The total is that 0,183, 0,183. So that is correct. Okay, so basically for both of these, we wanted to know what is the probability of getting an A in marketing. So it's that one. Probability of getting an A in statistics is that one. So if I ask you, what is the probability that you got an A in marketing and also an A in statistics, then it would be that one. Okay, so if it was an A in marketing and also an A in statistics, basically where those two join one another, that is where the AND will be. So that would have been probability of A in statistic and A in marketing. So that is basically the AND. Okay, so I don't think they've asked it, but let's look at what are the other questions. So event does not achieve a grade of A in marketing and does not achieve an A in statistics are mutually exclusive. Okay, so what do you think? Is that correct? Is that incorrect? Okay, so let's look. Does not achieve a grade of A in marketing. Does not achieve a A in marketing. Does not achieve a A in statistics. So we actually have a percentage there. So if it was mutually exclusive, then that should have been 0. Okay, so if it was mutually exclusive from our rules, it would have been 0. Okay, so that is not 0. So that one is the incorrect one. Okay, so let's just look at the other options as well. Events achieve a grade of A in marketing, and achieve a grade of A in statistics are independent. Okay, so when is something independent? So what do you guys think? When is something independent? Okay, so from the rules, when the probability of the one times the probability of the other one is actually equal to that AND. So if it is that, then we know it is independent. So if you times 0.29 times 0,183, if you get 0,053, we know it's independent. If we don't get that, it is independent. Sorry, the other way around. If that times that is equal to that, then it is independent. If it is not equal to that, then it is dependent. So when the probability of A, which is 0.29, times the probability of B, 0,183 is equal to the probability of A and B. So if that is equal to 0,053, we know it is independent. Okay, and I just worked out that sum, and it is actually 0,053. So it is independent. So when you do this assignment later on, if you look at the pages that I sent through this morning onto WhatsApp, you can use that. You can use this as well, nearly to say when is something independent and when it's mutually exclusive, and for you in the exam as well. So it's not that you're not allowed to use this, you can. So use it in the exam, use it nearly to get to the answers. You don't need to remember all the formulas, because even before you write the exam, in that few weeks before that, the lecturer will also send out a formula page that you can use. So when we are done with all the study units, I will send you also a formula page that I've created, that have been written things on it as well, to make it easier for you. Okay, so let's look at the last one in this. The probability that a student achieves a grade of A in marketing. So let me use a different color this time. So A in marketing, given that he or she does not achieve an A in statistics, does not. Okay, so how would you work out that? Yes.
Is the conditional probability formula?
Okay, great. So what would you do? What will you divide into what?
Okay.
So it's nearly this formula. So it's the probability of the and that is on top. So I'm just writing shortcut here, divided the probability of the event. So what's the probability of the and?
0.5. Oh, from the end. Okay.
Okay, so the and, so look at where the two purple, and that's why I like using the colors as well. So let's take out the rest of it is on the recording. So that was the one that we look at, and that's the other one that we look at. So the and is that one. So it is 0,237. Just imagine that is 0,237. And what is important, so what is the B in this instance? So given that he or she does not achieve a grade of A in statistics, so we will divide by the 0,817. So it's basically 0,237, which is the and, divided by the probability of that event, 0,817. Okay, and that will give you that answer. So again, it's nearly, doing it online is again different, because it's very easier to visualize this nearly in front of you and draw, and because that is that's how I used to do it as well. So it's very easy in a sense to say visually to assist you if you say, okay, we're looking at this column, we're looking at this row. So then you can look at what the numbers are that you can work with. Makes it a bit more difficult when it is online and you really need to start writing it down on a piece of paper, and that again takes time. So nearly again, why we want to do the assignments online is nearly to give you that opportunity to practice the whole time, that suddenly you don't need to work from paper-based back to the online environment and lose time. So it's nearly to to encourage you the whole time the online environment. So this is nearly, if I think of it, where the most of your calculations can come in, because this one, it nearly had four things that you needed to calculate. Well, five, because you needed to look at mutually exclusive. So you needed to calculate that. You needed to look at independent, so you needed to calculate that. So in this one, you actually had five calculations to make, which is nearly the worst case, because you will see a lot of the other ones, maybe you only need to make one calculation. So let's look at the next one. So again, if you look at this, you probably need to look at four calculations. So hopefully there's one that maybe just stands out as being incorrect. So again, I like to draw the picture. So probability of A1. So the probability of A1. So what they haven't done with this one is they didn't give you the totals. So to get to the probability of A1 is 0.4 plus 0.2, which is 0.6. Okay, so we'll complete as we see what we need to do. Okay, so probability of A1 is 0.6. It is correct. Probability of B1. Oh, okay, now we see here, so that should have been B2. So again, this is taken from that extra um, study assistance. So just check the question 4 on study unit 4. There is again a writing error there. It should be B2, but probability of B1 is then looking across 0.4 plus 0.3 is 0.7. So that is also correct. So what is nice about this type of question, the same as in question this table, is if I ask you A1 and B1, then it is basically A1, B1, where does it cross? At 0.4. So A1 and B1 should be 0.4, which is correct. So here you didn't need to work out anything else when using what is in the table. So you didn't need to work out the extra probability because it was worked out already for you. The same when we look at A1 and A2. So the probability of A1 and A2, can you get that? Can you be A1 and A2?
Um, I think you're supposed to add 0.4 with 0.2 and get that 0.6 from A1, and then you do A2, which is 0.3 plus 0.1, and you get 0.4, and then you add it together. I think you're supposed to get 1.
Okay, so what you now did was not working out the and, but working out the or. So it's good that you now mentioned it, because very easy to make that mistake, and that's why I want us to work through these. So what you now did was to say it's all of the A1s or all of the A2s. Okay, so you basically looked at the A1s and you said all of the other A2s as well. So this what this calculation is for or, not for and. Okay, so the same with B1 and B2. Again, here it is for and not for or. If it was or, it would have also been equal to 1. Okay, so in this instance, I want to use a different example because it's very difficult to see with A1 and A2, B1 and B2 what we want to do. So let's say that A1 and A2 was the province that you stay in, and we say A1 is Western Cape, and we say A2 is Gauteng, and B1 and B2 is, let's say B1 is work and B2 is not working. So if I told you that you're staying in one of the provinces, you can't be in A1 and A2 at the same time. Okay, so when we say A1 and A2, it is always 0. The same for B1 and B2. We can't say you're working, but you're also not working. So this is when something is mutually exclusive, is when it is basically looking at the same variable. So if it was hair color, you can't, and that can dependent if you use a dye or something, but let's say your natural hair color, it can only be one color. You can't, the same with your eye color. It's nearly, you can't have green eyes and blue eyes. So this is the same with this kind of things. It is, you can only be in one. So when it is looking at the two that is next to one another, it's always mutually exclusive. You can't be the one and the other one. And that is why it's always 0. Okay, so that one would have been the incorrect one, while that would have been the correct one. Okay, so basically you can't be A1 and A2, so it's always equal to 0. I will show you. So the same with this. You can't, and this is also a nice one to use. You can't achieve a grade A in marketing, but also not achieve the A. So it is, you can only achieve one of the two. So that is why those two will always be mutually exclusive. It will always be, if it's the and, it will always be equal to 0. We will get to one or two more on that. I don't think there was any of the voting things, but even if you look at it from a, let's say, voting, and you can't vote ANC and DA at the same time. Okay, so it's nearly to say the two are always mutually exclusive if it is like that. Okay, let's look at another example, and I have seen that they use this type of table as well. Cool, but you need to nearly complete something. Um, so again, I don't want to complete everything. So let's look at, and nearly a tip for the exam as well, because to complete everything, you need to make a few calculations. So let's look at what we need. Complete the numbers missing above table and calculate the probability of A having dry hair and the probability, oh wait, not dry hair, I'm now at dry. What is it? So I assume gas represents gas well completion. So dry and not dry, North America and South America. So you basically want to know what is the probability of A and C. Okay, so if it was in the previous tables, it would have been, okay, well, it would have been that answer, but here we are now working with the numbers. So, okay, I first need to work out that number. That number is going to be, so if I add that total, it needs to be 45. So that number is 14 because 45 minus 51 is 14. But also 14 plus 15 is 29. Okay, so we have this number is 14. And very interesting, if you look at the first answer, they give you 14. So what can also happen in the exam is you work out 14 on your calculator, you see 14 there and you want to say, ah, awesome, I got the right answer. But it is not 14 because you want to calculate the probability. Okay, so you need to say, well, 14 divided by something will give me that. So 14 divided by what? And again, I open it up to you guys. What would you say? 14 divided by what?
Fourteen divided by 45.
Okay, so you say 14 divided by 45. Okay, anybody else gonna try something? You can also just say in the chat what you would divide it through. Okay, so while the rest of you are thinking, okay, so it's not 14 divided by 45. If a question was conditional, that it said what's the probability A and C given that you know it's North America, then it would have been divided by 45. Here they're only asking us what is that probability of the and. So in this instance, we still look at the total sample of 70. Okay, so for this one, they didn't tell us given North America or given South America or given dry. Yes. Quickly say again. Okay, so let's continue. So basically, because they didn't tell you it's given as a smaller set, you assume that you're still looking at the whole sample. Okay, so that is when the 14, the and divided by the total. So if we go back to this, that would have been the same. So whatever that would have been in a number, it would have been that number divided by the total to give you the 0.53. So for this question, exactly the same, 14 divided by the 70 to give you the probability of A and C. And if you do that, 14 divided by 70 will give you the 0.2, which is option 5. Okay, so thank you for giving answers, because I think this is helping a lot of the students also to picture it nearly in front of them, because the start of probability is this section that we need to understand to nearly continue with the rest of the probability questions. So whenever I also need to stop and you need to ask me a question, please do ask. So in the first or second slide, I showed a lot of definitions. So let's see out of these ones what is correct and what is incorrect. Again, we're looking for the incorrect one. So the probability refers to a number between 0 and 1, which expresses the chance that an event will occur that is true. So also what is interesting from the previous question, so if your answers that you can get for probability must be between 0 and 1. So that is also why 14 could not have been an answer, because it's not between 0 and 1. Okay, so let's look at the next one. An experiment is an activity of measurement that results in an outcome. So that is straight from your definitions. So straight from the definition, that is correct. If the event of interest is A, then the probability that A will not occur is the complement of A. Again, that's straight from the definitions that we started off with. When events A and B are independent, then we know that to get the probability of A and B is probability of A times probability of B. Again, straight from the definitions, so it is correct. So this one is incorrect, but let's look at what the question is. The sex of students, males and females, cannot be used as an example of mutually exclusive events. And obviously, I think when we started with this, I don't think you will get a question like this anymore, because when this book was written 3 years ago, we were in a different period. So when it was only male and female, obviously things have changed. So obviously this question will not be in the exams anymore, but yes, so let's see. This is an interesting one if they do that in the exam, because then you can say that is also incorrect. So that was supposed to be the incorrect one. Okay, so let's move on to the next question. So now you see the first 2 or 3 questions, they gave you a table, and from the table you nearly needed to work out what the probabilities. Now they give you just it in writing. So now it becomes a bit more tricky as well. So when you get something like this, it nearly tells me that you will need to make a few calculations. So you now nearly need to have the set of possible formulas next to you. So let's start at the top. If events A and B are mutually exclusive, then A or B is equal to 0.8. So let's do that. So let's rather start with when let's do that. So for probability A or B, it is basically probability of A plus probability of B minus the probability of A and B. I'm just going to write it like that. Okay, so let's see. We've got probability of A, 0.5. We've got probability of B, 0.3. Okay, so if something is mutually exclusive, we know that the probability of A and B is 0. So then this answer would be 0.5 plus 0.3, which gives us 0.8, which is correct. Okay, so yeah, very important to know so knowing that something is mutually exclusive, we know that the probability of the A and the B will be equal to 0. So if I would have put this in the exam as well, then the next question I would ask you is, if it wasn't mutually exclusive, is the independence one. So if event A and B are independent, so what do we know about independent? The probability of A and B is equal to the probability of A times B. So when we do it for independence, it is basically the same formula. So let me say it will be exactly the same formula, but we will have different numbers. So it will be 0.5 plus 0.3, and then we need to subtract the 0.5 times 0.3. So when something is independent, we know that to get to the and, we need to multiply the two probabilities. Okay, so that would have given me something. I think 0.15. So that would have given me 0.65. Okay, so then we know that one is the incorrect one. Okay. Let's just look at the other options as well. If events A and B are mutually exclusive, then, and we back to the conditional one, probability of A given B is equal to 0. So the formula for this is, and how I remember this nearly, but again, you have it on your formula pages, but how I remember this is I just put the and between those two for the top, and whatever is the symbol for the last one is what is at the bottom. Because it's mutually exclusive, the and is always 0. So 0 divided by anything is 0. So that would be correct. So whenever you have mutually exclusive, so if it was probability B given A, still A and B is 0. So then your answer would also be 0. So remember, for mutually exclusive, the and is always 0. So if events A and B are independent, so if it was independent, we know that the and is 0.15. So now for this one, we know the and is 0.15. Probability of B is equal to 0,3. So 0,15 divided by 0,3 will give you 0.5, which is correct. So basically, again, nearly saying, remember what independence mean, and with independence, probability of A times probability of B gives you the probability of A and B. Then the last one is nearly a combination of the two. So if A and B is equal to 0.2, so then basically it tells us it's not mutually exclusive for this one. So if A and B is equal to 0.2, then probability of A or B is equal to 0.6. So we can basically use that formula again. So it will be probability of A, which is 0.5, plus probability of B, which is 0.3, minus the AND, which is 0.2, because that is what they give us this time. So 0.5 plus 0.3 gives you 0.8, minus 0.2 gives you the 0.6 that you are looking for. Okay, so that would be also correct and how you would have calculated that. So basically, nearly out of these set of questions, you had the table that was already in a probability and they asked you some questions. You had the table that wasn't in a probability, it had the raw numbers and you needed to calculate the probability, and then you can get basically where they not using any tables and you need to work with nearly the formulas that you have. And again, not need to memorize it, you will have it on a sheet. Okay, let's just do a quick check-in before we continue to the next two. So I think we can definitely complete the last two questions that we don't need to, that we can start to study Unit 5 then on Thursday. Happiness on your side that we can continue to the next one? Okay, cool. So let's go to the next question. So again, here they give us probability A, probability B. So what is now interesting? So we used to work with decimal numbers. Now suddenly they throw in fractions as well. So please, again, if when I see this, I would automatically first change it into a fraction, into a decimal. So 1 divided by 4 would give me the 0.25. 3 divided by 4 would give me 0.75. Just that I don't need to work with fractions. I just want it as simple as possible. So basically what they want you to work out here again is the conditional function. So probability of A given B. So again, how I explained it, at the top, probability of A given B is just the probability of A and B. And then at the bottom that you divide with is the one that's at the end, so it's probability of B. Okay, so the AND, they don't give it to us. So how do we calculate the AND? Anybody that wants to try that one? How do we calculate the AND?
The probability of A times the probability of B.
Great. So they tell us it is independent. So because it's independent, it is the probability of A times the probability of B. and that then divide by the probability of B. Okay, and then you see something very interesting. So at the top is a 0.75 at the bottom. So with maths, you can just cancel that out. So the answer is 0.25. And that answer is actually the same as the probability of A. Okay, so the answer would have been option 2. So I don't know if this is in the rules, but I think it is in study unit 4 in one of those at the beginning pages. So if two events are independent, the conditional will always be equal to one of the events. So if it was needed to work out the probability of B given A, that answer would have been equal to probability of B for this where it is independent. Okay, so again, you can go and work that out. The probability of B and A is exactly the same. It will be 0.25 times 0.75. The probability of A is 0.25. So in this instance, you would have calculated the 0.25 and the 0.25. So in this instance, you would have had that the answer is 0.75, which then is equal to the probability of B. So when two events are independent, you can nearly say when this happens that the probability of A given B is automatically the probability of A. And you can check your answer if it is one of the options. Okay, so here they ask, one of the options was need the value of P, probability of A and B. If I didn't give you that, so if I just said two events A and B are such that, then that would have been your answer, because then you can't calculate the probability of A and B. But because they used independent, you can calculate A and B. Okay. So again, I think that for me is nearly critical in your exam as well, and also check in your assignment. So when they talk independence, mutually exclusive, then they're already giving you some information. And sometimes that is just the extra information that you need to calculate the answer. Okay, let's look at the last one. So here they ask us, so they give you the numbers, and this is nearly the worst case if you get something like this in the exam, because you nearly need to work out a few options. It is not given as a probability, so you need to make every time real sure that what you are doing is correct. So this is nearly worst case if you get something like this in the exam, because unless your first one is nearly the incorrect one, then we're happy, but sometimes it is not. So we're looking for the incorrect answer again. Probability of M. Probability of M. Okay, so how would you calculate the probability of M?
$25 divided by 200.
Okay, so what you are doing with that is you're actually working out the probability.
Just the one, so it's actually 150, the whole
Perfect.
column.
Perfect.
Sorry.
Yes, the whole column. And that's why I like this interaction, because it's very easy to make that mistake, because that is how quickly you look at something, but it's the whole column. So it's 115 divided by the 200, which I think is correct if I look at yes, so that first one is correct. So unfortunately, so let's look at the other options. So there's M and P. So that is what you actually was looking at. So there's the male, there's physics. So that divided by the 200 will give you that answer. So let's quickly see, 25 divided by 200, 0.125. So that is also correct. Okay, so how I normally also would have done it in the exam is nearly to look for the easiest ones to do first. If I look at M and P, okay, so M and P, that one was, so for it to be mutually exclusive, M and P needs to be equal to 0. So if M and P are 0, then it is mutually exclusive. M and P is not 0, so it is not mutually exclusive. So that one is also correct. And this is also something that you will pick up in your assignments as well, is nearly the phrasing. So we will get to even study unit 5, 6, and 7, where sometimes they use words like most than, smaller than, more than. So again, not mutually exclusive means mutually exclusive. So events A, M and P are not mutually exclusive. So are they not mutually exclusive? Yes, because there is an and. So then it is or option 2 or 4. So which one will be the easiest to calculate? Probably let's go with option 2 first. So probability of M given P. So the probability of M given P is probability of M and P divided by the probability of the last one, which is P. So divided, sure, that just looks weird. Okay, so the probability of M and P was 0.125. So we can use what we have already done. The probability of P is 50 divided by 200. So 50 divided by 200 is 0.25. So 0.152, 0.125 divided by 0.25 is equal to 0.5. So that one is also correct. So that one would be the incorrect one, but let's calculate that as well. So the probability of C or F. Sure. Okay, so that is, so to do that, it is basically probability of C plus probability of F minus the probability of the AND. So I'm just putting in the AND there. So probability of C would have been 60 divided by 200. So 60 divided by 200 is equal to 0.3. And important to divide it by the total and not just by the total C. Oh, wait. I made a mistake. it is actually not 60 divided by 200. It's the total of C. So let's just use another color. So it is 100 divided by 200, which is 0.5, plus the probability of F. So that is 85 divided by 200, which is 0.425. And then we need to subtract the and. So where that and that meets. So 40 divided by 200, 0.2. Okay, so 0.5 plus 0.425 minus 0.2, and that will give us 0.525. Okay, which is when, no man, I made a mistake. 0.5 plus that is 0.9. So 0.725. Okay, which you can see is definitely not the answer. So again, something that you will notice, and you would have seen it in some of the previous assignments as well, the same numbers, just in a different order. So sometimes, again, in the exam, can easily make the mistake to read it wrong. But that is definitely the incorrect one, because it should have been 0.725. Okay, so that's the end for study unit 4. So nearly you could see with the examples that I took out for this study unit, it's nearly a mix of the possible questions that you can get. So it's one that is already a table within a probability, then it is the raw numbers that you need to work out probabilities. The one was also that giving you some of the definitions that you need to work out. And then there was one like this, where you basically get the decimal without tables and you need to work with the formulas. Okay, so that's the end of tonight's session. Quickly, let's just do a check-in. Are you guys a bit more comfortable with this, understanding it a bit better? I'll again post the video later tonight that you can work through it again, but does it make a bit more sense?
Yes, it does, definitely. It
Okay,
helps.
cool. Okay,
Yes,
awesome.
it does.
Okay, and as you
Yes, it is.
go through it again, please, on the WhatsApp, you can send questions around it again. So, and I assume all of you are in the WhatsApp group, but also send me a message if you're still not on the WhatsApp group. Okay, so that is basically it for tonight. I'll see you guys again on Thursday evening at 6, when we can start with study unit 5. I don't think we will get study unit 5 finished, because it is quite a lot of probabilities that I want to show you how to do it, and using the tables and things like that you don't need to work with a calculator. So I think that is the important part for study unit 5, is to show you guys how to read the answers from the tables, and not to use the calculator, because it just takes so much time. Okay, that is it for tonight, and then I'll see you guys again on Thursday.